My name is Paul Druce, and I'm the SE manager for Arista, covering ANZ. Firstly, who's heard of Arista before? Couple? Okay, good. So, I've been with Arista for about 5 years, and it's certainly changed a lot in terms of the types of solutions we're helping customers solve, or problems we're trying to help them solve. It started, with data center switching as the primary focus, high frequency trading as well. And then today we're presenting at a Red Hat Summit and talking about our virtual router solution and how we can automate that running in OpenShift clusters, but also how you can use it across multiple different environments. So, a couple know about Arista. How about network engineers or consider themselves experts in networking? Couple, okay. Well, hopefully you get something out of this session, at least to share with your peers in terms of being back with your network engineers. And I guess the idea with what we're trying to help customers with is it's no longer just a siloed network engineer's job to just look after the on-premise networking kit. And so how we use EOS, our extensible operating system, and how we integrate it with automation platforms such as Ansible, as you've heard in previous sessions earlier today. It's kind of bringing the network piece into that as well. So just a brief intro in terms of Arista. So as I mentioned, very focused on data center switching initially, but very much grown to helping particularly large-scale cloud customers and service provider customers, enabling them with high-speed switching ports. So in terms of 100 gig switching ports, we hold about a 44% market share in that particular market, and about 15% market share in the 10 gig switching world, so specifically for data center switching. And fast-growing company, ever-growing revenue, lots of new customers all the time, and we have hardware platforms, we have software platforms, and I'll talk about those, particularly the software platforms today. But what we do is we take a chip from a merchant silicon provider, such as Broadcom, or Cavium, or Barefoot, or Intel, and we take that chip and we put it into our standardized systems. So what that means is that whenever a new chip is available from the silicon provider, we can quickly take it and program it into our systems and place it into the system and use programming methods that we've built over the last 10 plus years in specializing, being able to do this for customers. So what that means is that we've essentially enabled networking to get on to Moore's law, like in the compute world. So every 18 months, 2 years, there's double the density for half the cost. And we've seen that in more recent years move very quickly to having 32 ports of 40 gig in 1 RU to now having switches that have 32 ports of 400 gig in 1 RU. And that's a very rapid change. So one of the most important figure on this slide is the one down the bottom, the one operating system. And that kind of leads into what I'm going to be talking about today. We have the one extensible operating system, we call it EOS. Now that operating system works on the hardware platforms. It works in virtualized form to be able to run it on an x86 server, or to be able to run it in a public cloud environment. We also have that same EOS one binary image to then make it available in a containerized format as well, to perhaps be running it on third-party hardware. So these different areas that we're catering for now. Lots of different roles in terms of helping customers in different areas of their networks. I won't go through all these in the interest of time, but I mentioned looking at data center switching. We are starting to introduce our innovation and technology into the campus networking space as well. We have hardware platforms dedicated to providing a lossless Ethernet fabric for IP storage. Lots of new technology around being able to increase visibility for customers in terms of their network operations, and that translates from physical to virtual, as we'll see later in the session. Addressing use cases around secure segmentation, secure encryption between data centers, providing data center interconnect capability. and also addressing a number of new markets such as service provider routing, taking what was traditionally done in a big router and doing that instead in a small switch. And that's a combination of merchant silicon being able to handle additional features and scale that those environments require, but also through the innovation in the software that we're enabling that kind of scale. And then lastly, IP broadcast. So another area or another vertical where they're shifting from an old way of doing things to a new way, being SDI, very coax-focused world of broadcast video, and that's all transitioning to IP. And that's something that we've been very heavily invested in globally, but also locally, with a number of great customer references doing that transition with us. So lots of different areas. And I guess if you look at all those areas, and there's some common themes, right? So traditional networking is moving towards what the cloud guys do in terms of networking. And it's kind of captured in a number of key areas. So firstly, automation, right? So network engineers no longer have to go box by box with the little blue console cable to do configuration for a new device, or even just ongoing. So everything's automated. When the switch comes out of the box, it's in zero-touch provisioning mode. So enabling that auto-provisioning of the standing up of a data center, but then also having network-wide control of that once it's stood up. Customers are wanting to transition away from proprietary solutions. They want open architectures. They want standards-based approach to solving problems, and that's something that we've instilled within our in our solutions from the start. They want greater control and programmability, and not just being able to script to something, but in some cases being able to develop an agent that runs on the switch to do something customized that they want. So having that capability in EOS as well. And I'll explain a little bit more about that. And of course, as we saw, not many network engineers in the room, but the skills that network engineers have are not irrelevant, right? You're still architecting systems in ways that use standards-based protocols, approaches to things. You still need to architect networks in the right way. You still need to be able to troubleshoot networks, and but this is evolving to introduce new concepts around automation using DevOps tools, or introducing new virtualization techniques like VXLAN. So it's an evolving industry, and it's really driven by what the large cloud providers did around 10 years ago as they started to create these large mega-scale data centers. So if we look at the spectrum of customers, Arista customers, they tend to fall into one of these areas, right? So we have customers with plenty of in-house skills, and they choose to leverage the API available within the switches, and they choose to use that scripting to automate the provisioning tasks or general upkeep of their network. Like I said, they may be leveraging the SDK to develop their own agent to do something that they wanted the switch to do that it didn't do out of the box, so we enable that. Today we're talking about Ansible, so there's plenty of customers that have invested in Ansible and other DevOps tools, and so we have customers that have wanted to transition that for the networking as well, both the physical and the virtual. The virtual or containerized sitting at perhaps the edge of an OpenShift cluster, which we're going to see today. And then, thirdly, we offer an out-of-the-box solution with our CloudVision software. A customer, they want to automate their network, they want to automate configuration, software management, streaming telemetry for increased visibility. So we offer a product that helps there as well. Now, quickly to step through just a quick about the architecture of EOS, because it's entirely relevant when looking at how we then take this piece of software and put it in virtualized router form, as well as then what we get out of that in terms of real-time streaming telemetry, both for the physical and the virtual. So you'll often see in a lot of our material talking about EOS this very simple diagram, right? It's a centralized state. This is the diagram in the middle. Centralized state, and think about that as all the state information that exists for that switch or router, and whether it be physical or virtual, everything that exists, such as MAC address tables, routing tables, LED status on the physical switches, environmentals, everything that exists as state exists in this database. And then the circles around the outside represent agents or processes that run to do a particular job. So there'll be a spanning tree agent, there'll be a routing agent, there's a VXLAN agent, and they run and they do their job, and they communicate with the centralized database in a publish-subscribe model. So they run and do their job, they publish that state back to SysDB, they subscribe to SysDB for the state that they're interested in. And that enables a number of things. So firstly, it enables us to provide a highly resilient software architecture. So those agents can stop and start independent to the forwarding plane of the switch because the state is independent to the agents. Okay, so that they might, it's a computer under the covers, it might be a memory leak, the process might fail or it might stop, and then it restarts itself and gets its state back from SysDB. Now this also enables us to have the ability to hitlessly patch the software. So in the same way, let's say there's a vulnerability to a particular RPM, it's Linux under the covers. So let's say there's an RPM we want to patch, we can stop that agent, or stop that RPM or that process associated with that RPM, we can patch it and have the system start again, all without impacting the forwarding on the switch. So this is important when it comes to both the on-premise and the public cloud or virtualized instances to enable, always-on networking, right? Not having to bring down the network to apply patches, etc. Lots of things around the outside. We can run Docker containers on the switch. If you have an application you need to run directly on the switches, the same for KVM. I mentioned RPM. A bunch of extensions that we offer as part of partner solutions, whether it be the likes of Splunk, Palo Alto, and of course Ansible's agentless, so we go directly. Now the streaming telemetry piece, so you've got all that state, so now as that state changes, I can stream that off in real time. So this is the opposite to what SNMP does for network management. So we're not polling devices every set interval and then maybe smoothing the averages in a graph. This is as a metric changes, we're sending the delta in as it changes in real time. And this could be to an open source tool. So we have customers doing that where we're just streaming that state to the open source tool. Or it could be to our CloudVision platform where we offer a number of components to that enhance that data. Okay, so I've mentioned these three different versions: on the switch, EOS, virtualized EOS, to be able to run on x86. We offer a virtual EOS lab version of that, which is freely downloadable from our website. The virtual EOS router is what we're going to be talking about next. And we have containerized EOS as a way of helping customers wanting to use third-party hardware, but taking advantage of our software architecture and the kind of resiliency and scale that enables. So looking at the solution for today, so we're looking at the virtual EOS router piece of software. So the same EOS that runs on the switches, the same runs across these environments, which means that we can use something like CloudVision to manage the on-premise, as well as the virtual EOS router instance running in our public cloud. Now, it could be running across multiple public clouds, and that's the AnyCloud part of this, right? So we've now got the same networking stack running in AWS, in Azure, in Google Cloud Platform, in our on-premise, and we have a consistent way to manage those networking environments. And we can use something like CloudVision to help automate that in addition to Ansible, or use CloudVision for streaming telemetry. Okay, so let's look at a little bit of detail about this solution. So firstly, what problem are we trying to solve here? So firstly, many customers, you probably know better than me in terms of the OpenShift environments, but many customers are deploying OpenShift clusters for multiple reasons, whether they're multiple administrative domains, maybe like I suggested, there's on-premise, there's in one public cloud provider, there's A, and then in another public cloud provider B. And typically, to move data between these clusters, traffic has to egress one cluster, go through its NAT, its egress gateway rules, etc., and then go across and then to the destination cluster, and apply the same on ingress into there. So this is the problem we're trying to solve, fairly simple problem, but something that we can bring some common networking concepts to the table here to help make this easier. So just stepping back in terms of looking at what the OpenShift SDN provides. So on a Red Hat node, you'll have Open vSwitch running. When it comes to communicating between nodes within a cluster, it'll be using a VXLAN overlay to be able to communicate intra-cluster. And then whenever traffic needs to exit a cluster, it's going to use a tunnel interface, which is the TUN0 showed here. And so when traffic exits TUN0, that's when the natting applies, and traffic is going to be treated in the same way if it was destined for the internet as if it was destined for some other external destination or some other OpenShift cluster. So this is the solution we're putting together to help kind of solve this problem. So as I mentioned, we've got AWS, Azure, and an on-premise data center, and we've got virtualized EOS running in each of these clusters. Now these are separate clusters, and essentially what virtual EOS router is doing is creating a secure tunnel between these environments to enable traffic to flow between these clusters without necessarily having to go through any NAT component. So essentially enabling a more seamless interaction for services that may be communicating from one to another. And then where Ansible comes in is, you're perhaps already using Ansible to automate the OpenShift clusters. So in a similar way, we have modules available to interface with Arista EOS, and we're going to use Ansible to automate the provisioning required on there in terms of creating a tunnel, changing the routing table to go across that, traffic to flow across there. And specifically, the Ansible is going to go in, it's going to provide an alternate path for some defined prefixes. So let's say OpenShift cluster on the left, the prefixes that are in OpenShift cluster 2, we're defining a different next hop. So the next hop being the virtual EOS router as opposed to the default gateway via TUN0. We're also going to use Ansible to change the NAT tables, so the IP tables, to essentially say avoid natting these source destination flows. Instead, it's going to get routed to the tunnel, and we're not going to NAT that traffic. So very simple. A bit of detail about this solution. So I've covered most of this, but essentially I'm going to show you a demo of what this does in terms of simply doing each of those three things when it comes to adding a new cluster, using Ansible playbook to be able to do each of these three things, being adding a route, modifying the IP tables, and adding a tunnel interface and routes to EOS. Now, one of the couple of important things to note on here is one, this is a solution for inter-cluster traffic. It's not going to impact the intra-cluster traffic, meaning intra-cluster is still going to use the VXLAN overlay. And any traffic normally destined for external is going to continue to use that TUNNEL0 interface to egress that particular cluster. And then we've got a subset of traffic that we're going to shoot over the VPN tunnel. All right, so let's have a quick look at the demo here. So how clear? It's reasonably clear. So very simply, this is a host running an Ansible playbook, and it's going to go through the process of connecting to a cluster. It's going to do those steps that we outlined before. So essentially adding a route to the remote cluster to be able to say that these prefixes, I want to instead route to the virtual EOS router instance. It's going to go and modify the IP table rules to implement that, avoid natting these particular source destination flows. And thirdly, we're going to add the routes to the virtual EOS router. So we're going to firstly create the tunnel interface. So now this is interfacing into the Arista switch. It's again using a similar format for sending the data to the router itself. create the tunnel interface, and create the associated routing required. Once traffic hits this router, what do I do with it? So, and it's providing that the rules required for that. And then we get our typical validation back from Ansible. All right, quickly moving on, running out of time. But what I wanted to cover next is now I've got my on-premise data center or that solution before. I've got my virtual router, EOS router, in each of these locations. I've got EOS in those locations. I may have physical on-premise equipment as well. And I've got EOS that is capable of doing that streaming telemetry out of these environments. So this is all about getting visibility of the network or the underlying network in a consistent way. So I've got my virtualized EOS routers now streaming telemetry out of the edge of the OpenShift cluster. And I mentioned before, everything that exists about state on the physical or virtual device is state that gets streamed to CloudVision. And we stream everything, right? So we send everything when it first initializes, and then it's just a delta of what changes. And then it's the application that can then determine, okay, what's interesting? What am I going to do with this data to represent it to my users? So CloudVision is built, in this case, we're going to send it to CloudVision, and CloudVision has an underlying infrastructure, which is essentially, I described that state on a device. It's now got a network-wide view of all that state. So on top of that database, I can create applications. Now, one of them is a provisioning application, which some customers choose to use in combination with Ansible. It might be doing more of the software management side of things, alongside Ansible doing the day-to-day provisioning for, as part of one system. We can also use Ansible to automate the provisioning of the CloudVision appliance itself or virtual appliance itself. Now, one of those other applications is the telemetry application, and that's the one I'm gonna show you a quick demo of today. So within this application, telemetry application, we're receiving all this data, and we have analytics engine that's it's interpreting all this data, working out what's interesting, and is there something that's going to create an alert? Is there something that I then need to trigger, an external communication based on that alert? I can drill into device specific information, or choose from a bunch of different metrics that are available that I might be interested to go in and troubleshoot. And I'll show you a bit of a demo of that as well. Now, we're streaming state out of the devices, and what I've described so far is more what is defined as native EOS, so that's NetDB structure that or state that I'm streaming out. And like I said, there might be an open source tool that's consuming that if it's programmed to interpret that data, but also OpenConfig is another means we can stream this state out of the devices if customers investing in tools that talk OpenConfig. All right, and let's have a bit of a demo. This moves a little bit quickly. So this is an events view. Events down the left, summary in the middle, timeline down the bottom, my watch. I'm even wearing the same watch today. So I've got an alert coming in, right? So via Slack, this is sending out an alert based on a BGP peer going down. I'm receiving that. I'm then going into my CloudVision and drilling down into this BGP peer going down. Maybe it was the virtual EOS between clusters that went down. So I can use CloudVision Events View to drill down into that. In this case, this is the particular event, and I get a kind of a correlation of different metrics that I might be interested in, and getting a side-by-side view of that. In this case, I see that a peer went down, and I get a bit of a historical view, so what was happening before and after that change. Seeing neighboring peers in terms of seeing if they're still healthy. Even routing table information. So based on that event, what prefixes were actually removed from my routing tables? So this is different from jumping on a router and doing show IP route and hoping to catch the network changing, right? So this is a rolling snapshot, essentially, of all the state on the network. So I can use this to then drill down and get a comparison of the particular routing table at a particular point in time, get a view of what was added or removed, but also then get a view of these snapshots based on particular outputs from the device. In this case, my BGP information, my EVPN information, and essentially a diff view of what you would typically get out of the device. So if I was on that switch or router doing this show command at this point, and I did it now, give me a side-by-side view of what that looks like. Next one, so let's say I've got congestion on my network, probably more typical of an on-premise physical use case, but I might be seeing congestion in my network, which may not necessarily be leading to drops, but essentially getting early warning of congestion based on receiving this information from the hardware on the devices. Other typical things, getting a view of the interfaces that are on my network, like a summary of that, and then being able to drill down into those network interfaces. Getting a view of the current throughput or error rates in this case, and give me a view over time. And these aren't averages that are being captured from SNMP. This is information that's streamed in real time as those counters changed on the device. In this case, we've drilled down into that interface. We've got optical levels that are low on a particular interface. So we've also got the neighboring interface information. We just get that via LLDP out of the device. So then maybe we've got those few different pieces of information. We want to go and see a correlative or a side-by-side view of that same interface on one device against the other neighboring interface on the other device, and see a number of metrics associated with that to really help me drill down into what the problem might be. And this is very different to the visibility that network engineers are used to having. So this is a physical view, and it's not shown on here, but you also get to see into the virtualized environments within this topology view as well. But essentially a physical map of the network, but then because we understand all the state that's coming out of the network, we have all that data, we can then overlay that onto the physical network as well, and get an understanding of where there's heavy bandwidth utilization, maybe there's congestion, maybe there's errors, and essentially overlaying that onto the physical. In this case, drilling down into where there's errors that we're seeing at a particular host level, and then using that to go to the server operator to maybe identify that there's a dud cable if we're looking at errors. So that was a bit fast, sorry, but hopefully that was helpful. So CloudVision is really something that we is designed to work with EOS no matter where it's deployed in the network. Largely the point of this session was to talk about how that virtualized router, EOS router, can help you in OpenShift environments, and how we can automate both the OpenShift environments and the virtual EOS router with Ansible. And then all these things that customers are using for managing their on-premise, applying to virtualized environments as well. So thank you for your time.